How can academic fields, the newest to HPC, best be encouraged to make the most of what is possible? How can we deliver more science? How can we help these new communities deliver more science? Who'd like to kick off?
I think that the best you can do is to publish what you're already doing and to explain to them that don't close your mind to the fact that it's physics or whatever. Just keep going around and having, I mean, we do these open days, and we do seminars and things like that. You've got to keep telling people what is possible, and just give examples of what somebody's done in English language, somebody's done in history. I mean, archaeology. They've all got use cases which have got lots of data and have got lots of time span data, and it's just you just have to keep putting it forward.
Yeah, I would agree, actually. I think in Edinburgh I spent a bit of time going around talking to disciplines who do not use high performance computing, but they know they're facing masses of data that they want to do something with. There is huge interest and enthusiasm for trying to exploit the data that they've got, but they do not have the experience that those of us, particularly in the physical sciences, have. They don't really know how to get started. And I think there is a real opportunity, and I think we've probably almost a responsibility that those of us who do have an understanding of how to exploit this sort of technology to reach out and help them get involved. There's huge energy, enthusiasm and ideas coming from disciplines that previously haven't engaged, but they're really keen to engage. And I think where we will benefit is that they will generate new ideas, new approaches to solving problems that are relevant to us. People are doing work. I mean, it's a sort of a simple example, but the breakthroughs in machine learning over the last few years have a lot of connections with the physical sciences, as it turns out. These are systems, and there's a lot of crossover happening now between people who have expertise in physics, people who have expertise in machine learning, and so forth. That's a sort of trivial example, but the ideas will flow both ways. And I think if we reach out and encourage, there's a lot of very exciting problems out there that may well benefit us and give us new approaches to solve some of the problems we're interested in.
Multidisciplinary teams are increasingly being set up in research groups, and they are cross-fertilising their ideas.
I think I would add one further thing. I completely agree with everything that's been said. I think the one thing that we have a responsibility to do, those of us who are working with, we are the service providers, essentially the teams behind the machines, the people driving the technology and the software, we need to recognize that the way we program supercomputers, computers in general, but supercomputers in particular, is not easy to get into. It is the very fact there's an MSc in high performance computing that you take after you've done an undergraduate degree tells you everything you need to know. I needed to do that in order to make the most of my PhD in physics. And there is recognized in computer science that the way languages have been written is terrible. It was written by a computer scientist, but it's used by other people, and we know this is a problem. We use C and Fortran predominantly on HPC systems. We need to realize those are very low productivity languages. I dread to think what would it be like if we moved to C#, but maybe we need to start thinking about things like C#. I might be out of a job because I'm a Fortran girl, but we need to look at how to make it easier to. It's again breaking this barrier down, making it easier for these people to engage in what is a fantastic resource for their research.
I would say that over the last 4 years, the revolution's actually happened, without many people perhaps realising it. If you look at where the largest investments are going in from government and research councils, it's not into the traditional HPC areas. It is going into medical research. You'd be amazed how much economics and social science is investing in this area. Biochemistry and biology. If you look at their forward plan, it's far bigger than mere physics. And so the so-called new areas, in terms of their aspiration and ambition, it's enormous. Take Tony's point, though, that there is a supply problem. So there is a problem in that there is this huge aspiration. There is a recognition of enormously exciting research to be done. It's actually getting enough people with the right skills in place to do the research is actually the main challenge. So the revolution's happened. We physicists, we don't dominate anymore. Not for 4 years.
How would Brexit impact UK HPC? And I'm looking first at Richard.
Yeah, so that's a really easy question to answer, actually. So this, I think the answer is really, you have to focus on tier 0, because the level of HPC that is provided by Europe is the tier 0 systems. And for the last nearly 6 years that PRACE has been operating, the UK has paid almost nothing for access to those systems and has got back, I think, something like 10% of the entire, if you like, resource. So we've been getting our tier 0 computing more or less for free for the last 6 years. Now, even if we stay in Europe, Europe is sort of increasingly feeling that we, Britain, should be paying more towards those facilities because we're getting so much back. So I think that situation I've described is not going to persist even if we stay in Europe. But of course, if we leave, then we will definitely have to pay through the nose for access to those systems. Well, at least I would imagine that would be the case. So we've been doing extremely well for the last 6 years, and it could only be made worse if we leave.
Any other comments from the panel on that topic?
It's a tough one, but I mean, it's the knock-on as well, isn't it? It's if you have this Brexit, then Scotland might have a different view of...
Oh, it's certainly true that Scotland will continue to have access to tier 0 because we'll continue to be in Europe.
Yeah. But the counter-argument is probably that with the money that you save from not being in Europe, you can buy a big machine of your own. So, I mean, they're all... we don't know enough, really, about... and that's the criminal thing, really, that we're all going to go into this vote. And I don't think that we're going to know enough to make an intelligent decision. So it's all going to be gut feel, and I've just come back from India, so my gut feel might not be very good.
I mean, the one argument that's sort of against that is at least the aspiration of tier 0 systems is to provide systems that are not affordable by a single country. Mm-hmm. I think that aspiration has not actually really been realised, but it certainly was, the raison d'etre for trying to create an international level of HPC facilities. It's proved very challenging in Europe to actually, achieve that.
Okay.
Yeah, the knock-on effect is the big one, and nobody really knows how it will play out. But okay, so for people in this room, how many people use tier 0? Probably me and maybe a few others. Yeah, okay. So it's not going to have a huge impact potentially, but what will happen is we will be forced to use a different resource instead, and it will trickle down. It will mean that there's less to go around of what's here unless we replace it, which we may well do. What also concerns me, and again, it could play out in many ways, is the potential brain drain. A lot of the projects I work on are European projects, so that gives me a bias. that would cease to exist eventually. I'm not sure how quickly, but it would cease. At which point, if I want to work on those kind of projects, I'd be looking at either moving into Europe or moving to the US. So to continue on those sorts of research topics. Obviously, we could have a different way of doing it. We don't know how it's going to play out if that such a thing happened, but it will change how we do HPC. But then HPC is going to change anyway. I'm trying desperately not to give my own personal opinion there. I hope that was a fairly mellow.
You'll never guess what I was doing this morning. I was actually writing a report for SFC on this very matter. So, it's fair to say that the UK has done very well. We've used 8% of PRACE resources over the last 5 years for essentially nothing. That's going to change. There is a PRACE Council meeting in April, and as Richard says, they've caught up with us, and we are going to be made to pay what we've used, for what we used. And it's, at the moment, it is very doubtful that we'll get anything like the 900 million core hours that we've had over the last 5 years. So, in terms of Brexit, for me, the question, although it has a long-term implication, in terms of immediacy, I think the question really is does the UK actually invest in its own UK exascale resources, tier 0 resources, that we could contribute at a later date into PRACE. I and others have been spending about 2 years now trying to work out and build the case for that. It's going to take a long while to actually convince government to put in the 250 million pounds to actually fund that. But I think there is now a willingness within government to listen to that. And that's irrespective of Brexit. As I said, the Continentals have caught up with us, and they're not going to let us get away with this anymore. So we have to make a decision. Do we actually play at the tier 0 level itself, and do we make our resources available to our continental partners? So that, for me, is the real question.
As the use of high-performance computing becomes more ubiquitous, how can we divide up compute time amongst researchers effectively and fairly?
Oh dear.
I mean, that's the question. Fairly. There's a fairly. That's a bit of a subjective word, isn't it? I do know that we spend, there is a governance group that oversees the operation of power of Grace and of Region that spends 2 hours a month thinking about this. It looks at an awful lot of data, an awful lot of historical data about system usage, looking at patterns, looking at trends, looking at exceptions and understanding why those exceptions occur. Both systems are highly contended. They are full all the time. So we need to spend a lot of time, we need to invest a lot of time thinking about this question to make sure that the systems are delivering the best value for UCL according to the research priorities which have been set by David Price and senior management. So this is something we think about a lot. So I'd like to invite the panel to offer any comments on this, but I'd also like to invite several of you in the audience who are members of that monthly governance group to offer your comments also. Who would like to kick off?
I can speak from considerable personal pain,
Yeah.
which I think Jeremy probably shares, given the grimace on his face just now. So I had to set up the peer review process for PRACE, and the challenge there is, or was, that we had applications from a number of different disciplines, but they were all in the physical sciences. I think we put in place a very rigorous peer review process within disciplines, but we frankly never managed to understand how to compare proposals for time from different disciplines. And at the end of the day, it becomes, to some extent, a subjective judgment by a group of scientists who just do the best they can. And frankly, I haven't come to a better solution than that. The only thing I would add is I think the pain is going to get worse, because as we have many more disciplines competing for access to these resources, we're going to be facing this problem in spades. So I don't think there's a good solution. High quality peer review is a component, so that at least you understand within disciplines what are the good proposals and what are the bad proposals. Between disciplines, you have to fall back on some subjective judgment of the importance of the science, political interference, your institutional strategy. I mean, there are these things which sort of operate at this higher level, and I think it's going to be very challenging, to be honest. So I don't have a good answer. If someone does, answer on a postcard be most appreciated.
Buy more, yeah. Lenovo will say, buy more. There we go.
I think that will help.
Yeah.
That obviously is going to help. But, I think we will see competition for large amounts of resource. I mean, it's fine if you've got lots of groups competing for small amounts, and then you can sort of fit them all together. But when you start to get, groups competing for the whole machine, or whatever that means, you're going to have to make some of these quite difficult decisions.
And of course, buy more is not
Sustainable.
Well, number one, it's not sustainable. It doesn't necessarily solve the problem. One of those of you who've been working in high performance computing for some while will know that the appetite of computational scientists for computing resources is insatiable. So great that we're doubling the size of Legion in the summer. That's fantastic. But it'll still be saturated again within a few weeks after putting that capacity in. Because what happens is, it isn't just more of the same kinds of science, it's new science. You double the size of the system, it can then support new types of problems. So what our scientists will do, what our researchers will do, quite rightly, is to think, aha, I have a bigger system. Not just I can get more of the same work done, but I can now attack problems that are quantitatively different, qualitatively different to those that I was running 6 months ago before the expansion happened. So so there is no such thing as enough, as you know.
I think another aspect which I mentioned in relation to the emergence of probably several quite different architectures over the next, say, 5 to 10 years will be how, as a country, do we, or at the institution level as well, choose to spend our money. If there's a set of applications that require this particular architecture and another set of applications that require that architecture, who makes the decision as to which gets the money or how much money goes into which system? So, there's lots of quite difficult challenges to get this right. Jeremy's looking like he might have an answer, but I'm
Jeremy,
skeptical.
tell us about the Dirac approach.
The Dirac approach, oh dear, it was rather a brutal approach.
Yeah.
Wasn't it, Richard? So about 4 years ago, Dirac, which represents theory work in particle physics, astrophysics and nuclear physics, we provide HPC resources for that lot. And we basically had about 14 systems. We got a refresh from BIS in late 2011. And we actually did quite a very deep review, a very hurried but still a very deep review of how best we look at we actually order and organise our resources. And at that time, we were running 14 systems, and we consolidated, or I prefer to use the phrase aggregated, down to 5, which left a lot of people unhappy. But what it enabled us to do was buy more effective and more well-balanced systems that were particularly oriented towards the different problem sets that we were faced with. And this has meant, as Claire has said, is that people were able to do more and different kinds of science. And it's been incredibly successful. But it was brutal at the beginning. We're not used to rationalising or consolidating. But we did it. I'm also from an observational background. I'm an astrophysicist myself. So for me, it was kind of in the blood that we rationalise and consolidate, because we've been doing that for 40 years when we're building the great telescopes. Wasn't quite seen like that on the computational side of the fence. Looking ahead to what we're thinking about the national e-infrastructure, as Tony has said, HPC is going to change again. And the co-location that you've seen already, which Owen and Julian have talked about, is going to become more common. There is now a pressing need upon those of us who can to both share and aggregate our systems up. So the approach that Claire was talking about and others were talking about, that's now going to start happening across domain. So Dirac's an example of it within the domain. It's going to start happening across domain. So there are big changes ahead. But what I've talked about just now is the peer-reviewed sector. There is a distinction to be made. I was asked about 6 months ago, what's the difference between university HPC and Dirac? And the essential defining difference, actually, is that Dirac's and Archer and Prace are peer-reviewed. Science case, you've got to send it out to referees, it comes back, it's all very intense and the epitome of peer review. University HPC, not really. And I would hate to see that go. I would hate to see University HPC become that bureaucratised, because I think you would be putting a barrier, a big barrier. Sure, ask groups what they think they'll do. Ask groups to say what they think they will actually produce over the next year or 2 years. Hold them to account, by all means. But maybe not go in for the full, I'll say horror then, but I'll use the word, but go for the full horror of peer review. Peer review does improve excellence, okay, but it improves the excellence of what is already there very much. Whereas I think University HPC allows something to exist in the first place. And I think that is something that we should bear in mind. So be fair, by all means. But do trust to the wisdom of your colleagues. 2 theoretical physicists, me and Dario, we actually picked a poster about viruses as being the best one. We were able to make an academic judgment. Bear that in mind.
I suppose the exciting way is a raffle.
Yeah.
A lottery.
Yeah.
A little raffle.
I would like to see part of this is making sure that people are using, 1, the right resource, and 2, the most effective use of what they've got. And that's not going to solve the problem, but I think it's an important component. The number of people I come across who complain to me that running their code on Archer, it goes slower, and I'm like, have you looked at the scaling? Is it even parallel? How did they get onto Archer in the first place? Given that it's peer reviewed. We need to educate, especially as we get new communities come in, we need to educate them about what is the optimal number of processes to run on for what they're doing. We need to tell them whether or not they should be using a local resource, a regional resource, a national resource. We're the experts. It's our duty almost to kind of help them with that. We shouldn't be expecting them, they're an expert in their niche. Why should we be expecting them to become an expert in what we are as well? We need to bring them along, we need to educate them, if that's not too patronising, so that what we have, the limited resources we have, go as far as we can.
Thank you. I know there are several members here of our own governance group that thinks about these problems every month. Would any of you like to comment? Dario? Dario is chair of our academic-led governance group that looks after this problem for us.
What I would say is that I agree completely with what has been said so far. In fact, I wanted to pick on the two words, effectively and fairly, which are not necessarily, they don't necessarily go together. I mean, you may argue that if you want to use the resources effectively, then you do peer review and you allow only the best projects on the machine. Fairly, I mean, probably with fairly you mean you want to give everybody the same chance to access the resource and to test what they're doing. On Grace and Legion, it was decided a long time ago, well before I came to this group, that there will not be any peer review of the research going on to the machine, that everybody would have the same chance to get on the machine. And this is how the system is being run at the moment. And so what we do every month is to see if there are any anomalies, so any researchers who get anomalously large proportion of the machine, and if we see that, we try to understand why and try to make it more even among the different researchers. We found that the policy that seems to work quite well at the moment is what we call functional share. So basically there are two kinds of priorities. If you don't have anything running on the machine, your priority is high. If you have one job, even one single job running on the machine, your priority becomes low. So that means that you go at the bottom of the queue, right? And this seems to work quite well even in the field for all research to access the machine. But I agree completely with what Jeremy has said about these kind of machines have to be there to give everybody the chance to develop their research. And you know, the best project then will go to tier 1 and to tier 0 machines, but tier 2 are really to allow even playing field.
Thank you, Dario. What kinds of changes to the current education system would we need to see in order to raise the number of women going into computing careers generally?
There's a huge number of things I could say here. If we're talking about tackling school level, so it depends what we're talking about computing careers. If we're trying to get school children, school girls, to do a computer science degree or a computational physics degree or some flavour, we need to get rid of the geeky boy in the bedroom image, which is what I had when I was a teenager. I didn't touch computers until I came to university. I just missed out. I'm a bit too old to be of the generation where they, ubiquitous for email. Emails were just really taking off when I was leaving home. We need to make computers less. I'm not even sure what the word is, but we need to make them just more appealing. They are cool. We need to get that across. The problems they can solve are really cool. So we need to get that across to schoolgirls, as I was saying in my talk. And then the second image is, how do we get the women who are doing something computational in their degree to pursue a career in computing of some flavour? And that is largely down to image and role models again. It's about showing women, one, there's a career route, that there's something exciting to do, that you really are going to change the world, that you're not just going to be sat in an office not talking to anybody, even though that might be what we do some of the time. You know, there is a route there. I strongly believe a lot of it is about image. Once we then get them there, then there's a retention issue, which I already discussed. But I really believe that a lot of it is to do with image, and that's a responsibility on every single one of us to go out there and change that image.
I think it will be interesting to see, as data science takes off, what effect that has, because there will be new communities, disciplines getting involved where there's a better gender balance from the outset, and they're now starting afresh. So they don't necessarily have the history. So that hasn't answered the question, and I think if I knew how to change the curriculum, we would all have done it. But I think we are definitely moving into a different phase of the use of computers. They'll be used in many more different ways by a much greater variety of people, and whether that creates opportunities to address this problem, I don't know, but it certainly seems like we're going to go into a different sort of context.
Yeah, I do think you hit the nail on the head there, which is we've got all these new communities coming in, and we sort of have a duty of care to figure out what the issue is now. I haven't managed to actually show it. I've got provisional data that does show it, that although biological sciences in the UK is 45% women in academia, we are getting even fewer women coming from biological sciences than we do from physics. So, okay, even when we have a group of women, they aren't engaging with HPC. That's a big problem. If that continues into humanities and social sciences as we branch out, we've got a huge issue. We're just going to have the social sciences, there's going to be such a small number of them that engage with us. Is it down to the operating system thing that I talked about, Linux? Do we need to get education about Linux in schools, or is the onus on us to change the way you interface with these machines? As I mentioned, we need to perhaps lower the barrier there. Linux is not an obvious route in for many people. I don't have a silver bullet. If there was a silver bullet out there, we'd have solved it already. There are enough people that care about it, I'm afraid to say, but it's not simple.
Can't really add any more to that.
Any other comments or perspectives on that challenge?
And just
Javier.
just ask, so following up on that, you mentioned in your presentation earlier that the percentage of women in HPC or in computing processes is fairly low.
Mm-hmm.
How about the percentage of trainers?
So in the UK we do quite well. Well, from my perspective we do, in that the main place I see trainers is with the national training programme through Archer, and we've got 30% of our staff on that are female. We also run women in HPC training events, which is a completely different dynamic. I was quite sceptical about it when I set it up, but it's a fascinating thing to observe if anybody's interested. So I think we do okay in that particular arena. I think we probably do very poorly in educating our physicists. In Edinburgh, for example, I'm pretty sure every single lecturer who teaches the computational physics courses throughout the whole degree programme is male. We will have female postgrads helping, but I've not looked at it in detail, but I would imagine that those standard routes in, you're lacking female role models, definitely.
Thank you. Question from Samantha.
Kind of more comment. I kind of said it really, that we have a wider cultural issue. Our society tells us that actually it's not for girls. If you look at Wired, every advert in there is written for a man. You look at the covers of T3 and stuff, there is a scantily clad woman or something that is aimed at a man. So yes, we need to sort out our education, but actually we need to sort out our culture and say, hang on, this is for everyone, and make sure that is very, very inclusive, because we can do what we want, and I taught ICT, I try to get my girls into it, but there is a massive switch off. They're brilliant till they're 11, they hit puberty, they see Teen Vogue, and bam, it's not for me anymore. And that is a shift, and I'm really annoyed with Kinder Eggs and those sodding pink and blue things they've just brought out. By the way,
How do you get the computer people, whoever they are, to keep the cabinets so tidy?
spend a lot of time doing it.
Don't touch it.
Don't touch it. So, systems administrators in the room, Simon.
Okay, I'll stand up for that one. I'm just really angry about it, that's all. Just listening to it. But the point is, the systems of that complexity, they don't work if you're not tidy. You really, really have to be careful. So the integrators will tell you this. The way you assemble a system, the way you make sure the wires are all screwed up nice and tightly and they're not clamped in the doors and all the connectors are done right, is the difference between a machine that works and one that kind of works a bit but fails lots of user jobs.
And labelling.
And labelling and colour coding the wires and keeping it cool and all that kind of stuff. That makes the platforms you're running your programs on that much better and that much more reliable.
So, just to say that we have to pay incredible attention to detail. We have to be very tidy-minded, and we have to be very good housekeepers. I think that's what we do. We're very good at housekeeping.
And you put it in the contract from your colo site that says if it's not tidy, they're going to switch it off.
Yeah. Because all it takes, those InfiniBand cables that you saw, all you need to do is slightly kink it like that, and your system stops working. So incredible amount of care has to be taken.
They're very, very sensitive to bend and tension, aren't they?
Because for the physicists among you, you get lots of nice internal reflections if you bend it, which completely messes up the signal. So there we go.
So I have a follow-up question. Who cleans the machine rooms? Because you wouldn't let somebody like me in there because, I'm only allowed in machine rooms escorted because I'm a recipe for disaster. You'd understand if you saw my desk. So who cleans the machine rooms? Someone sign
I don't know.
Somebody must.
Special cleaners who like cleaning that kind of stuff. It's like me and Jeremy.
In the old days, I would go in there with my little Henry Hoover, and I would do it, because we wouldn't trust anyone else to do it.
I wouldn't trust many people, definitely not me.
Yeah.
House, you're looking after some very large systems.
Cleaning robots.
Cleaning robots.
Lots of cleaning.
What, like Roombas?
Wow.
You can tell he's got money.
Question. Should we encourage universities to diversify the architectural variety of new systems in order to explore all the options as to what works best? So should universities, most university systems, they're all kind of
You're the same.
they're not all the same, but
Oh yes, they are.
variations on a theme.
Not much.
Should there be more diversity?
Simple answer, yes. So I think Jeremy probably is going to agree.
I am going to agree, and the reason I agree is that until recently I was the chief surveyor of the National E-Infrastructure, so I know what all your systems are like, and they're all the same. So, I think this kind of goes to looking to the future. We've got the so-called regional consortia and universities working together in various ways. I actually see a great role for you in doing what Dirac did, which is to actually, because that's essentially what we did. We've got 5 diverse architectures, which means we can address 5 different problem sets. And the more the university sector looks at this and trusts each other to actually enable you to specialise, you can start to aggregate very large resources surprisingly quickly to actually solve very large problems. And that's certainly what my advice to BIS has been. So.
Yeah, and as I said, I think you didn't hear my talk because I was trying to push this argument. I think there is a growing recognition that we have to do this. And this does come back to what I keep saying. diversity of, the diversity of applications is growing, the diversity of architectures is growing for the foreseeable future. We need to understand how to develop software, basically, and applications in that environment, and that means we have to be able to sort of explore the various options that exist both in hardware and in software. So I think the big challenge, and there is really seriously active discussion about this. I mean, Dirac has been able to do it, but Dirac's been helped a little bit by the fact that it is focusing on some fairly specific disciplines with relatively well-defined computational models and so forth.
That's right. Yeah.
We have to learn how to do this across a much broader range, potentially, of applications, workflows, architectures, etc. So I think the challenge is, how do we encourage? How can we, as this is sort of the issue for the UK's national infrastructure, is how to incentivize the universities and the sort of tier 2 level to work in a sort of coordinated fashion, so that they're not all doing the same thing, and that we can grow expertise across a much more diverse range of applications. But how do you incentivize universities to operate that way when they're also, to some extent, in competition with one another, etc.? So I don't think we have an answer, but I think there is a recognition that we need to find a way to do this.
Well, the answer is not the way that we're currently seeing in tenders, where you get we want 1,000 cores of x86, and then we want some little play pits. We want one NVIDIA thing and a Phi thing and something else. That doesn't work. We approach it by having stuff in-house where people can run proof of concepts, just to run test cases and see if that works on different architectures. And we do that by getting the vendors to give us the kit. So, because with the conduit, but you'll only ever, a lot of answers to these questions, it's leadership, and wherever you want, it's that the leadership has got to either dictate, because my preferred method of management is benevolent dictatorship. If you get, and I think it might be yours as well, Jeremy. And if you get that leadership right, then the rest of it will sort of follow. And then you've got to get leadership A in line with leadership B, and that means you've got to have a bigger leadership. So it's.
But it does come back to what I think Jeremy was saying earlier about allocation of resources. There's a bit of leadership needed, a bit of vision about where the institution, if it's UCL, where does it want to be, where does it want to get to, and then not putting barriers in the way of people who have new applications, actually helping them, providing them with the training and support, encouraging them. But I think ideally it really needs to be driven by or led by the science. I mean, I think it shouldn't be the architecture. So I see the second question here about GPUs. It shouldn't be we need a GPU machine. It should be we have this particular set of science problems or research problems we're trying to solve, and it turns out that a GPU-based machine is the most cost-effective way of doing that science. If it's posed that way around, that I think is the ideal. If you don't have, we were saying it at coffee, if you don't really desperately want to solve your problem, you're not going to put the effort in to change your codes for a different architecture, or to write a new code or implement a new algorithm. I mean, there's got to be the science drive, otherwise you're just not going to put the effort in.
Jonathan, you can comment.
Make a comment on this. So we talked about I think you called tier 0, tier 1 and tier 2 machines. I don't know whether what I'm talking about is tier 3, but I suspect that there are as many flops CPU used in UCL not run by ISD as there are run by ISD, and that diversity is terribly important for exactly this problem. And there was a move a few years in UCL to try and actually step down on this and try and centralise things. That's been backed off from, and I think that is absolutely essential in terms of diversity, so that people, you know, we fitted a GPU to one of our own machines, we're programming it, we're finding it's very useful, we therefore, part of people are actually saying, yes, we want to keep an Emerald type facility because we use that. But without the facility to do this in your own group at a fairly low level, you will lose that diversity. So that's very important, and that needs to be encouraged. So that a lot of it is actually just encouraging diversity, which UCL is rather good at in general.
I think we're entering a phase where encouraging diversity is absolutely essential for our competitiveness. We have been in the past, I think, at periods when there was a lot of common architectures being employed, where perhaps the pressure to go in the other direction made some sense. So our own institution also tried to centralize the computing for the reasons you just said. But I think it's something which does evolve with time, depending on where the technology is and where, you know, the application's interests lie. And we're entering a period of great diversity, is my sort of bottom line.
So I think we probably want, you know, one more question, Sigourney? Okay, well, Fortran or C++, well, this isn't going to be quick, is it? Should we do it with a show of hands?
Yeah.
Hands for Fortran. I'm abstaining, by the way. Hands for C++. I think Fortran takes that.
You should ask who's a physicist and who's not.
What do you think? We're same hands?
I think you might find there's a slight bias there.
Yeah. So we'll take one more. What is the future of Emerald? Are there any plans to host a similar GPU system solely for UCL? If you are the concerned researcher who sent that question in, please contact me directly so I can reassure you. We are not going to drop you in it. So yes, we're thinking about the future of the Emerald system at the moment. Emerald is a GPU-based system which is was established and operated by the Centre for Innovation, which evolved into the Science and Engineering South Consortium of universities, which includes UCL, Oxford, Cambridge and Imperial and Royal Natalie King's. It's now operated exclusively, but it's now run for UCL and STFC by STFC, and there are a lot of UCL projects which are still making great use of that specialist facility. So we're thinking about the future of Emerald at the moment, a lot of different options, but the system is not disappearing at the end of July. We will absolutely be continuing to provide a service and a graceful transition, no pun intended, into any successor system to meet the same needs, however so provided. But if it's you that sent that, please contact me directly so I can give you some more detailed information about that. It's 6:10 and we've had a long afternoon, and there are drinks and canapes downstairs. So I think probably it's time to wrap things up, which means that what I need to do now is to offer some votes of thanks. So I think, can you join me first of all in thanking our panel and all our speakers today for some fantastic talks. Thank you. I'd also like to thank our sponsors, OCF, Lenovo, Mellanox, Vertis and DDN. Also support from the Science and Engineering South Consortium, all of whom have contributed time and resources and energy and enthusiasm to resources, yes, to deliver a great event for us today. So thank you all. And finally, I would like to thank Sigourney. Sigourney Luce, whose day job at the moment is Sigourney is Communications and Marketing Officer for Science and Engineering South Consortium. But since October, she's been planning this event for us today. She's masterminded the whole thing. It was her vision. She's looked at every detail, every email, every logistical every logistical item that needed to be attended to in order to make sure that today has run as smoothly as it has. So Sigourney, please can you come up, and I'd like to thank you too. Thank you, Sigourney.